shit. That's what I'm talking about.
Wait! Okay, now, from the beginning.
Okay, so this is going to be a session on shader graph. It's going to be an introduction session, so I'm going to be going over the fundamentals of the tool and live building up a shader using all the built-in nodes. So hopefully it will give you a very good overview of kind of what the tool does, how it interacts with different systems, how to set it up, and all the different parts to do with the new shader graph system, which is coming out. Well, it's available now, but coming out soon. My name's Andy. I'm obviously not from America. I'm based in Brighton, England, / Copenhagen, Denmark. And I'm a content evangelist at Unity. So I build a lot of demos and build a lot of tutorials and workshops and come and give talks about how to use Unity features to make more interesting projects or better projects or faster or quicker or shinier and all those lovely things. So the talk topics are how to set up a shader graph in a Unity project. It's actually super simple, but I'm just going to show you how to set it up. An overview of the actual interface and the workflow, what it looks like, how you actually interact with the different elements. Let me put my coffee now. Creating visuals by using various built-in nodes, and I'll explain the concept of the nodes in the system and how they all work in shader graph terms. And some extra resources and information. This is actually a really big topic, and I've got like an hour 15, I can't remember what the schedule said. I could easily stretch this out to 20 hours. It's that big of a tool, so I'm going to try and condense down a lot of information to a small amount of time. But hopefully it'll be a good tip of the spear talk to just show you the right direction to go in. So just as a poll, I do this at the beginning of every talk, so like put your hand up if you're a developer, programmer, you copy paste code, okay, everyone. You put 2 hands up when you did it. That's cool. Put your hand up if you're an artist with a 3D or 2D. Okay, someone shrug. Okay, that's cool. Put your hand up if you're a game designer. Okay, cool. Put your work in audio. Okay. Put your hand up if you have no idea what's going on and you just saw like a bunch of people walk in a room and you're like, this might be cool. Okay, cool, right. I'm just getting like a general feel of who's in the room. So the concept of shaders. So this is basically, at its core, a script that defines the color of a pixel on the screen. And this can happen for every single pixel on the screen, and it determines, what color it is, whether it is transparent, whether it's shiny. All these contributing factors come down to what color pixel is on the screen. And it's used for everything that is rendered. Meshes, sprites, UI, particles, post-processing. I mentioned that someone else, they were like, post-processing is shaders? Oh my God, like mind blown. Everything is rendered, so it's ultimately an incredibly important concept for any type of digital project because everything is rendered on the screen. And before Unity 2018.1, they had to be hand-coded, unless you sort of use something like ShaderForge or like Amplify Shader Editor, or I've seen studios make their own shader editor and stuff like this. But built-in vanilla Unity, and I use vanilla Unity as like, all the stuff that is in Unity that we distribute ourselves, it's all had to be hand-coded before. So it kind of doesn't make sense. You've got this kind of, you want to define the color of something or the shininess and the shadows, but you have to write a lot of code to do that. And there's this kind of divide between these two sort of workflows. So they can require a lot of knowledge and complex maths and algorithms to be able to create, I just want to make it shiny. Why? I just want to do nice rim lighting. Why do I have to learn all this extra code to do this? Now, a lot of people here write code, so you're probably very comfortable with that, but a lot of people don't know how to write code. I'd argue more people don't know how to write code than do in the games industry. So we kind of saw all these other tools doing really cool stuff, both in Unity and outside of Unity, so we're like, hey, let's do one ourselves. So typically, you would have a lot of shader code just to determine something is shiny, something's red, blue, transparent, things like this. This is actual code generated from shader graph, which I'll show you how to do later on. And this would ultimately be represented in a node-based system like this. So this is actually exactly the same code. Shader graph can actually generate code for you, and it's generally readable. You may have to reshuffle some stuff around, but it is at a sort of readable format. So shader graph is a visual editor to put together nodes and combine different nodes to have end results or end effects. So as a high-level overview, shader graph is a visual interface to create shaders using no code. It's developed by Unity's graphics team. This isn't tech that we've acquired and are in the process of integrating, something like Cinemachine or ProBuilder and TextMesh Pro. This is actually tech that we've built ourselves. I think on Twitter, the developer of ShaderForge says, yeah, like I just wanted to go back to making games. I didn't actually want to continue working on tools. So we obviously is very aware that we were building this, and it's developed by our own graphics team, which is cool. It includes a vast library of built-in nodes. I don't actually know the exact number. They keep adding more. It's something like 200 plus at this point now, and I keep just giving up trying to know what the number is because they'll probably added 5 more during this talk. So there's a vast library of built-in nodes, and one thing, a lot of people here are developers, so one thing that I'm going to point out is you can actually create and script your own custom nodes and look at the source of the built-in nodes and kind of mix them together and take elements from the noise module and the time module and then build your own nodes out of that. We have a whole API to do that, which is really exciting. People are going to do some really cool stuff on the asset store. And it's available in Unity 2018.1, which you can download now in beta, and it's being released, I can't remember what they said in the keynote, April, maybe, March? April, thank you. Soon, yeah, as we always say. And it's currently compatible with the lightweight rendering pipeline as well. So, demo time. And techno music. So we have here a very basic spider robot, and if I click play, the spider robot is just in a very idle state. Very simple. I'm starting off very basic and baby steps, or in this case, spider steps. So we've got this spider that's standing and walking around. And what we want to do is we want to create a graph that has a type of visual, a type of effect on the spider. In this case, a rimlet dissolve effect using a noise, which seems like a lot of stuff that you often have to get a noise include file or function, and then combine that with rim lighting and do all this stuff. But because we have shader graph and all the built-in nodes, you can piece these things together very, very quickly. So I'm using the lightweight render pipeline, which is part of the new scripted render pipeline system that we're integrating. And as you can see here in my project folder, down here, we have the lightweight asset, which you can get from Package Manager, and download this into your project and set this up in the graphics settings. And a lot of people don't know this or haven't seen this tool that we're added into Unity 2018.1, this whole package-based system. And what we're actually doing with a lot of systems that we are integrating to Unity and building for Unity is splitting them into packages that you then import in. So as opposed to, say, going to the asset store and pulling it in, or going to GitHub and pulling it in, you have all these random locations that things are being, post 482 on a forum thread somewhere, magical. We've all tried to find that specific post. Instead, underneath window, we have a package manager. And this package manager window will show packages that are currently in the project and packages that are not in the project. And the all list is obviously a lot longer. So here, if I wanted to bring in TextMesh Pro, I could select and then install this package in, and then uninstall it as well. And then I can change version numbers, and it's basically a way of getting pieces of Unity and bring them in. I may be making a game that doesn't require shader graph or Pro Builder, but it does require post-processing, so then I only include kind of what I need in this interface. So to get shader graph, you just open up the package manager, select shader graph, and you would install it. It's sort of as simple as that, and then you have that whole system inside your project. Now, I've already got shader graph, but I've got it through a different means. I've got it through this lightweight render pipeline package, because we can have packages that contain other packages, kind of like, I guess, nested packages or package inception. So the render pipeline lightweight package would have in there some post-processing stuff, shader graph, and a bunch of things, all the things related to graphics. And my boss is now messaging me, so I'm going to ignore him and close Slack. Go away. Yeah. OK, I'll close. Yeah, it's fine. So you can then go to Package Manager and install in the packages that you need. So in this case, we've already got the shader graph installed. I wasn't going to rely on Office Wi-Fi during GDC. So now that we have our spider robot, if I go to spider robot's material, you'll notice that we're using just a standard lightweight material, which has like albedo, metallic, normal, occlusion. It's like a typical standard shader. And we want to use a shader graph instead. And it's quite easy to make shader graphs. You just go to your project folder, create the asset, go to the shader menu, and you notice here that you can still create and hand write shaders. We're not removing that functionality. People will still be able to do that, and they will do that for many, many years to come. People don't want to use a visual system. They like that way. So we're kind of putting them side by side. So you've got your handwritten shaders, and you've also got your graph shaders as well. So you can use both workflows. So I'm going to create a PBR graph. And let's call this spider robot. graph, GDC, why not? So you then have your shader graph assets. Now to open shader graph, there isn't actually a dedicated window, and that confused me at first, but I'll explain later on why that's a good thing. You would double click the graph, and it would open up the shader graph window and kind of fill your screen. I'm just going to close the door because there's people who have no respect for shaders, so they can stay outside. And then double-clicking the graph asset will then open up this window. Now, this window is just like any other Unity tool window. I can dock it to different areas and place it in different locations and resize it. But it actually works better when it's kind of full screen like this. So the way that this window works is it's built up of multiple parts. In the bottom right-hand corner, we have here the Spider Robot Graph GDC. And this is the preview of what our shader is going to look like. And you'll notice here, well, it's a sphere, so if I click and drag it, you're not going to notice any change, really. But if I right-click it, I can then change it to other forms of kind of mesh. And then you can then see the preview. Let's go to cylinder. Let's go to cube. You can then see a preview of what your shader is going to look like as you're building it entirely in the graph, which is going to be great for very quick iteration. You will obviously have to go back to your scene view and see what it looks like in the context of your scene, especially when you have shadows and stuff like this. But you have your preview here. And we have the new Graph API in Unity for creating windows, so you can actually reposition and rescale and do all sorts of cool stuff. One of the cool things is you can actually go to custom mesh and choose which custom mesh you want to appear in this preview. So I'm just going to choose the spider robot's head, because the spider robot's built up of lots of different meshes. So I'm going to use this as kind of my preview. Now, the next thing is we have this central sort of workspace. And this central workspace is basically the area that you connect all the nodes, and you build up your kind of node construct. And holding Alt, you can then click and then move around. And it also zooms in and out. We finally added zooming to Unity. This is amazing. So what we'll have here is we'll have all our nodes connected and sort of set up with all their settings and things like that in this sort of central panel. This top left panel, which I'm now bringing attention to, don't worry about it for the time being. But now everyone's going to be worrying about it from now on, so I kind of ruined that. One thing you'll notice here is that we have a Pbr Master Node. And in Unity Shader Graph, master nodes are kind of the outputs from the shader. So it's where your shader ends up, because you're going to have different nodes doing different calculations, but you ultimately need them to kind of output to a certain place. If you've written shaders before, like surface shaders, you'll recognize, albedo, normal, emission, you have all those outputs. And it's basically the same thing for our Pbr Master Node. You can also make an unlit master node, and people are going to write their own master nodes that do all sorts of really cool stuff. But in this case, we're shipping with Pbr Master Node for lighting and interesting things, and unlit for kind of unlit stuff that has no emission and normal and things like that. You notice here that we have a bunch of different slots with values going in. Now, what I'm going to do is, in this open space, you can either hit spacebar, or in this case, I'm going to right-click, and I'm going to create a node. And when you open up this sort of right-click create node sort of menu option, you'll notice that we have here this node menu. And we've taken all those nodes, 200 or something like that, and rather than making one big, long list that keeps going, we've instead sort of filtered them into different categories, like math section, or math, it's localized for American audiences. To me, it's maths, but yeah, that's fine. Input, master, procedural, UV, these are all the nodes that you can use to build up your visual. So you can then say, I want to go into artistic, adjustment. You can see a channel mixer, contrast, hue. I'll be honest, like doing a whole talk with like going through every single node, it would be like 1 hour per node, and no one wants to sit here for 200 hours. And someone here is like, yeah, actually, that would be really great. Please do. Don't sleep. So instead, I'm kind of going to fast track and go to some very specific nodes that do some really cool stuff. So one node I really like playing around with is Fresnel. So I'm just going to type Fresnel because it also does like kind of type search. So if I do F, it will filter all things with F and find the Fresnel effect. Now here you'll see a node. And the node will say what it is at the top. On the left, it's got the inputs into the node. And on the right, it's got the outputs from the node. And you'll notice here at the bottom, we have a preview of what the node actually looks like. And one thing we try to do with Shader Graph is put as much preview visualization throughout the whole flow of the shaders even through things that happen over time, like scrolling and stuff, you can then see the effect and the steps all the way down the river. You don't have to connect loads of nodes and then sort of guess what's happening here. You can kind of see all the nodes connected and what's actually happening. So we have this Fresnel effect, and you'll notice there's a bunch of inputs which are then going to be applied to some kind of Fresnel algorithm that's happening in the background, and then it's going to output a value. In this case, we have a sort of rim light. And you'll notice that here I've got a power value. So if I actually change the power value, you'll notice here that that value is then changing. And you can see very visually inside the shader editor, or inside shader graph, that as you sort of tweak these values, you can see the result in the preview for each of the nodes. So here I've got this nice Fresnel effect. Now this Fresnel node is basically useless by itself. It isn't actually doing anything. So I can click this output, and then you have this connection, and I'm going to plug this into emission. What you'll notice is that as I plug it in, you'll see that this effect is now being applied to this kind of Pbr Master Node, and our spider robot head is now kind of glowing. So you can see that as you plug in nodes, the preview will then change live for what you're doing. Now, this will be great if our game is just white Fresnel rim lighting around everything, but we want to change things like color, really advanced functionality like changing the color of something or changing the power of something. So what I'm now going to do is expose some values to the material inspector, which everyone here has probably used. So in Unity you select a material, and you have all these sliders and all these settings. Directly in shader graph you can expose values to this material inspector and change them. So if I then go back to my graph, I want to expose two things. I want to expose this power value. I want to be able to tweak, how much power my Fresnel effect has, and I want to also tweak the color. And this is where this top left-hand sort of panel comes into use. The thing that I said ignore, and everyone's been wondering what it does for like the last 5 minutes. This is what we use it for. What this is called, it's called the blackboard. And clicking this plus, we have all the different inputs, all the different values that we can actually expose into the material inspector. In this case, color, texture, cube map, booleans as well. You can also add little toggle buttons to turn on and off effects and things like that. Vector 1, 2, 3, and 4 for like X, Y, RGBA, RGB, and things like that. So I'm going to expose a color, and let's call this Fresnel. Actually, let's do something interesting. Spider color. Actually, spider Fresnel color. So we have that little property there. Let's increase that up. And clicking here, we then have a color picker. So let's set someone shout out a color, not black or white, pink. Cool. Beautiful. Magenta, exactly what we need for a shader workshop. We have this property here. Now what we can actually do is we can actually drag and drop this property into the interface. So if I drag this into the interface here, it will turn this into a node. So it's kind of making that connection between this sort of blackboard global values and then placing it as a node here. And we're going to combine these together. So we have this nice white sort of rim light around the outside edge. And we want to multiply this via whatever color this is, in this case, pink. So I can go to my node section, use a multiply, because we have basic maths like add, subtract, multiply, what everyone knows, I hope. And then I can then connect this into multiply, connect this into here, and then connect this into emission. So you notice that you can then combine these different nodes into the inputs and then get certain outputs. And it also means that if I go, sorry whoever shouted out pink, but if I then change the property, you'll notice that it's actually changing all the way down the river. So you've got your Fresnel multiplied by this color, you've got this master node here, and then you have your spider robot here. Now I'm going to do another change. I'm going to open up Windows thing. If I go to the property menu here, or this blackboard, and let's create Fresnel, spider Fresnel power. And let's give it a value of, say, like, I don't know, 2 or something. Drag this into the node interface and plug this into power. We then have, we have 2 sort of entry points. We have 2 material inspectors set up, one going into the color of the Fresnel and one going directly into that Fresnel effect. So we have a very basic graph set up, doing a nice Fresnel with color and with power. Now, if I want to then say, OK, this is pretty cool, but now we've exposed some stuff. Now we've got something visual. I want to see it in the scene. we then need to kind of go back to our scene and see what it looks like. So in the top left-hand corner, it's really difficult to see. We have Save Asset. So what this will do is clicking Save Asset, it will save the asset, I hope. When we go back into Unity, or back into the main Unity interface, and then I select the Material Inspector drop-down. Currently, they're actually changing this. It's all plugged into this Graphs selection, but I think they're changing it while I'm on camera, so I'm hoping they're changing this. They're going to change it so you can, like, in the inspect, you can change what the menu setting is, but currently it all gets put in one place for the time being. And here we have the different graphs. So I'm now going to switch to Graphs, Spider Robot, Graph, GDC. And then here we now have our Spider Robots, and let's click play. Spider Robot's having a look around. And then here in the Material Inspector, we've got the color and the power. We've got those exposed values. So the person who said pink, I'm now going to change it back to pink just for you. So you can notice here that you can then, everyone's really happy about that. So you can notice here that because we've exposed values and they're already set up in the graph to do some kind of effect in the graph, we could then set that up. And then, of course, I can then change the power effect and make my spider. Let's do something like make it like really, really red. Red seems to be the nice one for this spider robot. So yeah, we've now got a red rimlet spider robot entirely in the graph. Super cool. However, this isn't good enough. We need to go and make more interesting stuff. So what I'm now going to do is move all these nodes down. You can actually multi-select nodes. So if I drag this out and move all these nodes down, because you want to have a nice workspace, and we're going to get a texture and plug it into the albedo slots, because our spider robot is kind of gray and bland, and we want to apply some kind of texture to it. So I go back to the blackboard, click the plus, and select texture. And let's just call this texture, because I'm generally quite a lazy person. Now we have this texture property. So I'm just going to drag this in, so we have this texture input coming into the graph. Now the trouble here is if I then select this, you notice it's not connecting. Like, do you see it's not actually connecting? And that's because the texture has to be kind of sampled and converted into some kind of data format that the master node likes. So in this case, albedo has a number 3, so it's asking for an RGB value that's being output to it. Texture is a type T because it's a texture asset. So what we can do, one thing we've kind of factored in to stop people from trying to plug wrong data sets into other data sets and get something wrong, is if you have these nodes and drag them out to make a connection and let go, it'll open up the Create Node menu automatically, and it will filter it depending on what node you're linking it from. So that way you're not trying to plug a texture into like a color value or something like that. You instead have some kind of context menu that shows you, hang on. You then have this context menu that shows you exactly kind of what nodes are compatible with the property that you're using. So if I now go to Input, Texture, Sample Texture, you'll notice it automatically filtered what is actually useful in this case of this graph. It's white because we haven't actually given it a texture. But the really cool thing about this blackboard system is if I go here, we then have this asset selection thing. Someone called it the asset nipple at one point, and I can never get it out of my head. But selecting that little selector, you'll notice that I can say, hey, here's the spider robot texture, which I conveniently set up beforehand. And you'll notice here that it will show you the preview of it being laid out in the first UV channel. And here we then have RGBA and each of the channels that we can then play around with. So I can then, now that this is set up, I can now output this into albedo. You'll notice that the master node sort of sphere updates and our preview updates as well. So we now have our graph with texture being input into the albedo slot, and we also have a very basic kind of Frontal effect being put through the emission. We finished working in the graph view, so I can click Save Asset, go back to here. Hey, look, we've got a texture slot magically auto appears, or has auto been added. I can choose that same texture, and we can then see that workflow of exposing things, plugging in, exposing things, and plugging in for this entire flow. So we now have our spider robot with a nice Fresnel color, a Fresnel power effect. Who's the magenta guy? Yep, there you go. This is not a shader error. This is by choice. OK, I prefer red. I'm really sorry, dude. and we have the texture wrapped around it. So we have that kind of graph set up. Pretty cool so far? Cool, right, I'm going to do more complex stuff now. So if I can grab the window. There we go, cool. So one of the really cool tricks that I like doing is actually dissolving things. This is sort of something that I try to do all the time. Try to see if something can be dissolved. It's a really neat effect for bringing character into a scene and bringing character out of a scene. So I'm going to show you how using the built-in nodes you can do a nice dissolve effect. And this is kind of going to be the workflow some people are going to have with shader graph. They're going to have some kind of, I want to achieve this result, so what would be the node process to make this up? So if I then zoom out a little bit, because we have zoom functionality in Unity, finally, which is cool, and have a look at my master node. And you notice that we have two outputs here, alpha for transparency, and alpha clip, which is kind of like a clip, kind of like a mask that's being applied to our mesh. Now what I want to do is I want to basically use something to dissolve our spider robot. And one thing that we have built into this node, let me create this node when you're here, is a bunch of different procedural modes that using algorithms will create some kind of visual up without having to require a texture or some kind of input. So if I go into procedural, notice we have noise, and we have gradient noise, simple noise, and Verona noise. And let's create some simple noise. So we have noise nodes. Rather than trying to find your own noise function, which I've done so many times in writing shaders, we then have a magical noise node here. And we have a couple of inputs. So we have scale, so I can then like crank the scale down for the noise. So let's set this to something a little bit like this. And let's take this noise and output it through a step function. So let's pass this in here. And as I change this edge value, you'll notice it's going to take that and split that noise. So what this is doing is it's basically taking that generated noise texture, which is kind of sort of bumpy randomness in some way, and it's using step. And what step does is it returns either a true value, such as white, or a false value, which is black. And using that edge, we can then dissolve or sort of like set where that step is. Now, I am aware I'm probably talking complete alien language to some people, and that's sort of intentional. And that's because each of the nodes in this node-based system in shader graph have their own documentation page. Hooray. And we can right-click each node and open the documentation directly from the shader graph. So let's say someone here said, I have no idea what step's doing. Who's this weird English guy? He's just sort of saying a bunch of terms. You can instead open up the node, right-click, open documentation. Hey, look, we have a node. Returns 1 if the value, obviously we need to add some more information. It's still a new feature. Well, it's not even out yet, so that's cool. And it even shows the shader function at the bottom that's embedded into this node. So you can actually, if you're a programmer or developer, you can actually see what's happening in each of these nodes, which is really cool. Similarly, if I then right-click the noise node, you can then see what's actually going into this as well. And you see the inputs and the outputs. So it's a really cool way of actually understanding what all these nodes mean. And I actually spent, when I first started using shader graph, I just spent ages just plugging random nodes into each other and seeing what they did. And most of them didn't work, but it was super cool to sort of experiment. But here we then have simple noise and that step value. And what I can then do is take this and output this into that clip. So not instead of alpha, which is transparency, into clip. So it's going to basically clip the mesh. Nothing happens because I have to set the alpha to 0.5. But you'll notice here that we then have a sort of shredded spider robot of some form. Now, if I then expose some values, because I want to be able to determine how much noise there is and how much dissolve there is via the inspector. So what I'm going to do is I'm going to add a vector 1, which will just be a float value or something. Let's do noise scale. And let's plug this into that scale setting and set it to, I don't know, like 10. Cool. And let's create another one, and let's call this dissolve amount. So you can see the workflow is like creating these properties and then plugging them in and then being able to use them. Now, the really cool thing you can do here is for each of these values, you can actually set up sliders automatically appearing in the inspector. So I'm going to set up a slider between 0 and 1, which is super cool. And let's put dissolve amount into this step value. So you can see here that we have this flow here. Don't worry about remembering all this. I'm going to put this project online, or it's probably already online somewhere, so you can download it and just Everyone will have dissolving spider robots in every game ever. So if you make billions of dollars, I'll claim my 0.5%. No, I'm joking. But you can see here that we can very quickly add in these nodes built into Shader Graph, which are already there, and then expose different settings. So I'm going to save the asset, because saving is super important. There's one thing that I'm going to teach. And then we have noise scale and dissolve amount. And I can set this dissolve amount and then sort of scrub through this. So you can notice that we have here the spider robot changing. And then I'm going to increase the noise scale, because remember, the higher the noise, the more bumpiness, or the greater the spread is. So you can notice that we have this kind of dissolver effect. What you'll notice is that when you're entirely dissolved, we have kind of here the shadows being shown. This is actually a bug. So many people said, that's so cool, that's such a cool effect. Basically, the shadows don't get clipped yet, but this is the dev team know they're working on this, and it's being recorded, so they know that I'm saying this. Yeah. So what you can see here is that we have the shadows here, but that's something that we're going to fix. It's still in beta, so we're still working on it. But you can see here that you can then do a nice little spider robot dissolves in and then does something in your project. And if I click play, we can then tweak these values, change the noise scale. So if I actually decrease the noise scale, it's super fun to play with. But just exposing all this stuff and then being able to do all these cool effects is really, really fun. And of course, magenta person, we can then make it magenta. I know how much you were missing that. So we then have this kind of effect. Really cool. Now, one thing some people might have noticed, although probably maybe some people noticed, I'm not too sure, is that if we dissolve it, we don't actually see inside the spider robot, because normally when you sort of dissolve things, you'd see sort of the inside. It's like double-sided. Don't worry about that. I can then open up Shader Graph, which is now off screen, so that's great. OK. It's down here. Oh, shit. OK, Plex is awesome. Great. I cannot open Shader Graph. Where is it? So I've actually put it off screen, which is not particularly helpful. Oh, it's sounding so clever. But that's OK. I already pre-made it earlier on, so just in case this happened. OK, exactly the same shader. So here we have the same dissolve thing, but I've done some of the trick here, so let's just delete that. Just ignore all of that. And great, the photographer comes in when it breaks. That's super cool. So just pretend you're still like, yeah, wow. So one thing you notice here is we have this two-sided option. So if I turn that off, you'll notice that the dissolve doesn't show through the preview the other side of the dissolve, the clipped element. I select two-sided. Hey, look, we can see inside our spider robot. So if I now save this and go back to my scene, when we dissolve our spider robot, dissolve it by piece, you can sort of see that we can see inside the spider robot through the other side. So you can see that we can kind of do double-sided stuff, which is great for particles, great for like force fields, like if you played Overwatch and you want to do some cool stuff like that. So what I was going to show you is this. OK, it's off screen again. Great. OK, where is it? OK, what I'm going to do is I'm actually going to close Unity, because that seems to fix it every time. That's the foolproof. Oh, that's something I'm showing you later. OK. Does anyone have any questions so far whilst I'm quickly trying to fix this? No? Everyone is having fun? Oh, you have a question? Water. OK, so it really depends what type of water you're trying to create. If you want some kind of water that's bumpy or bouncy, or some kind of vertex displacement. So Shader Graph currently doesn't support vertex displacement, but it's coming very soon. So if you want to have water that bounces. Now, if you want to do some kind of refraction effect, Shader Graph you can actually input in like normal direction and camera position and stuff like this. So it would be a combination of a bunch of nodes, I think, because you want to get the camera's angle and then get the water and sort of distort it very slightly depending which angle the water's looking at, because that's generally how refraction works. One thing we do need to make is some water examples, because it's asked quite a lot. But I'd say a bunch of water examples. One for like, if you want to do water like Monument Valley, low poly water, and water that looks really, really nice, and water that's sort of toon shaded and stuff like this. So it'll be a combination of getting the camera's angle and getting the normal of the meshes, which you can get directly in the graph as well. Yeah, stuff like that, yeah. So, oh look, it's all fixed. So we have here our dissolve sort of effect. And what I wanted to do is, rather than dissolve, I'm not going to do that same thing that I did. OK, actually, that was the one that I wanted. Oh, I guess you just saw that you can actually open up multiple graphs at the same time. But I'll show you that in a bit. So currently what we're doing is we're dissolving it across the UV. Now, we might not want to do this. We want to do something more exotic, like dissolve it using world's position, or dissolve it using camera space and things like this. So if I actually go to the Create Node menu and go to Input, you'll notice that we have a bunch of things like Basic, Geometry, Matrix. That's not inputting the Matrix, the Keanu Reeves movie. Scene, which is really cool. You can get ambient lighting, camera, which will give you all the camera-like data, like position, direction, orthographic. Really, really cool stuff. People are going to do like all sorts of wormholes and all sorts of really cool stuff with that. What else is there? Reflection probe, objects, stuff like this. There's one node I really like playing with, which is position. And what position does is it gets the position of the particular sort of pixel on the screen somewhere, or position of the element on the screen, or in the world space or in object space. So you see here we can actually get the position both in object space, world space, or view space. So if I now do world space, and let's say we plug this into the UV. So it's currently in world space, so we'll save this. Go back to Unity. I won't move it off screen. You notice that as I actually move the spider robot, it's basically using the world position as the UV, which is super cool, because then when we go into play mode, the spider robot's going to kind of like, as the spider robot moves around and stands up, it's being sort of like dissolved, like, yeah. So rather than the wrapping around the UV, it's using the world position. Super cool. Instead, I could do something like, let's go to view space. So it's going to get the position from the camera. So now we have this really weird, like, sort of dissolving effect based on the camera. So if I now open up this material, fill the dissolve up, increase the noise scale, you get this really weird. Yeah, I hope people have, yeah. This is going to be the Unity party tonight, yeah. Guest VFX DJ, yeah. So you can see you can actually just plug in lots of nodes and sort of play around and get some interesting results. Now let's go to here and do something a bit more interesting. So we have this position. Let's go object space instead. So rather than wrapping around the UV, it's instead wrapping across the mesh itself. And there's this really cool node I like called twirl. And twirl will take a UV and it will twirl it, which it kind of makes logical sense, right? So for example, if I create the checkerboard node, you see that the checkerboard node is just a bunch of squares. It looks super great. And if I output twirl into the UV, hey, look, we then take that UV and then, So you can see how visual it is that we're like modifying this and playing around with it. And the cool thing with shader graphs is you can kind of like make all these like little ideas separately and all these little node structures separately. And then when you find something you like, then you can go back and plug it into your bigger graph. It's super cool. These all live over here. So I really like twirl. Twirl's pretty cool. So what we're going to do is instead put twirl in to here, output this, and save this. And let's see what it actually does in our scene. So it's taking the UV and then doing stuff like that. So let's do this and then go. OK, let's. Yeah, so you then have that kind of dissolve effect. So the cool thing is, oh, shit, I've done it again. No. Where is it? OK, never mind. Anyway, you can then dissolve stuff. So yeah, you can then take all these different ideas and sort of plug them in and do some cool stuff. Everyone learned something so far, hopefully? Wunderbar, right. So what I'm going to do now is I'm going to sort of switch gears and show you something else that you can play with. And this has been my pet project that I've been working on for a while. So this is a small shader graph example library. I'll put up the link at the end. And these are a bunch of shaders that I've put together. I think I made this lineup in like 2 days or something like this. And this is all public on GitHub. You could download them, play with them, tweak them, put them in your game, go for it. I give you full permission. It's all cool. They're all built using the built-in nodes that are directly in here. For example, we have, so here's the catwalk lineup. We have basic rim lighting, which you've already seen how to create. Pretty cool. We've got this kind of water, not entirely water, but this kind of scrolling sort of effect that's going over the top of our weird character. We've got this, this is quite fun. This is for all Apple adverts. So someone shout out a color, not pink. Blue. Blue, yes, thank you. Blue, and then someone shout out another color. Green. Cool. People usually go blue and then blue again, and then yeah, super imaginative. So what we have here is basically like sort of an example of doing a kind of gradient. So you can see that you can expose all these settings and plug them in. And it's across, instead of the UV, but across the whole object, which is super cool. We got sliced, which is actually a super famous shader on the Unity shader documentation on how to slice an object. So I recreated this directly in Shader Graph. I've worked in Unity a while, so that's kind of been, that shader's been an interesting learning resource that everyone uses. So we got sliced here, and then I can then go in and tweak, slice them out and cool stuff. This is snow. So snow basically gets the world normal up and then places snow on the top of the object. So here, as I rotate this character, you'll notice that we then got this kind of snow layer, which I can now play with a bit more. Let's add the snow depth a bit more, and then, So you notice here that when I select the character and then rotate it, snow's going to always appear going up. And then actually when the character animates, so when I click play, the character will animate on the spot with snow on his back. Yeah. So you can then take this and then sort of decipher it and then put it in your project. This is basic toon shading, basic toon ramp. This is dissolve, but kind of like instead of dissolve before, it actually uses this texture here as the dissolve map. So instead of like a generated noise, you can then, you can dissolve this over this texture. And it does like kind of like a subtle edge, but I can then plug in, let's do stars, so I now dissolve it over using, yeah. And here is something that's, here are 2 examples that are pretty cool. These are kind of shaders where things are happening over time. So if you've written shaders, you probably use the time function a lot. And we have a time node built into Shader Graph, which is super cool. So if I select this kind of strange hologram, which is based off of the view position of the camera, as you can see, like anywhere it's looking, it's scrolling from the top of the screen to the bottom. If I go in here and edit the shader, we then have the node set up. So I'll try to make these as neat as possible so people can decipher them and plug them into other things. You can see here that the element is happening over time. What we've really tried to do is in the previews show you what's actually happening through the entire chain of the graph. So if I do something like, okay, let's change the tiling and set it to be like 0.1, cool, I guess. Set this to be like 2. Okay, that's bad. Tiling to be like 3. Yeah, so you can actually change these values and see things happening over time all the way down. So you can open up this graph, see how I'm doing time with this time node, super basic, and then see how it's all flowing through there. And then save the asset and then go back. But all I was doing was changing properties. So yeah, colored noise, and then this is just a guy sliced in half. So who makes 2D games here out of interest? OK, so in this example, I've also added how you do this for sprites. Yeah, let's not save. So here we have shader graph for sprites. So we got that's the same hologram that I've applied to the sprite, so you can see how it all works. Here is just like a flickering. So if I go back here, and then I can set like the speed. So this one's pretty cool. This is actually using a normal map on the sprite, so I can actually take this light and then put it around, and you can see that I put it here and then the fronts of her legs. So if I actually pause it, okay, if I pause it at a good time, you can see that as I move that around, the normal map is then getting the influence of the light. And these are just 2D sprites, they're all flat. So yeah, so I've got examples of using graphs for sprites. Yeah, and there's a whole bunch more that I've made. I forgot to download the project, but on Twitter I uploaded this sheet, which is all lots of really basic examples of how you do, like, just rotating a UV. Okay, I have to click it to how to ping pong things, how to twirl things, how to do like wormholes. All these graphs you can just open up and then plug together. Actually, I think this one is actually a combination of this one and the rotation one. So you can take these and then use these as a resource to see how you glue together graphs. And one thing I really want to show you, because it's really cool, and this is a very powerful thing, is when you're building your own graphs, you can actually open multiple shader graphs at exactly the same time, which is very different to Unity before, where you have animation system. You can only view one state machine at any one time, or one timeline at any one time. Instead, we designed shader graphs so you can actually open up multiple shader graph windows together. So if I have this, this hologram one, I'm really fond of this one, and open this graph, and of course it's off screen, because we should totally work on that. Hey, there we go. So we've got this here. I can then dock this to a certain area. So let's actually dock this just here. And then let's say, for example, actually, let's dock this at the bottom of the editor. Just here. So you can see you could actually work on your graph. No, not Sketchbook. You can actually work on your graph entirely on here. Obviously, like my screen's quite small. That's fine. But then let's say, for example, I want to combine that with, I don't know, like snow. Why not? Hologram snow. And then we have this whole snow sort of graph set up. I can then actually dock this here. And you can see that you can actually open up multiple graphs at the same time. And I think in this build, because this build's like a few weeks old, you can't do it, but you can copy-paste nodes to other graphs and stuff. So you can take the hologram. So if you download the example library, you can open up the hologram one, your own one, and then sort of port stuff over. And it's really, really cool being able to do this and open up graphs. Or like my monitors set up in the office is usually one graph here, Unity project here. So I'm playing around with different things. Really, really cool. So yeah, if I now go back to okay, I'll continue without that. So here we've got the shader graph example library. So if you actually Google, I think, Unity shader graph example library, it's the first hit. I don't think there are any other ones, so that's super cool. And I work at Unity, so hopefully that's, yeah. So you can download this repository, play around with it, experiment with it. If you use it, send me an email or a tweet or something like that, and let me know what you use it for, because it's super cool. And let me know if you have suggestions or you want to contribute and stuff like this. I'm trying to sort of like take the contributions and neaten them a bit, because I've been sent some like 400 node monsters, and I need to kind of distill them into bite-sized examples. Making stuff performant? It really depends. Okay, I'll segue into this in one sec. So one thing that a lot of people have asked a lot is, okay, how do we actually see the code that's generated? Because this is super important performance. So here's sort of the trick on how you would see the code that's generated. So each of the shader graph files, you can then compile the code like you can normally do with a shader. Now, one of the cool things you could do with shader graph is you can actually right-click the ends node and copy that shader that's currently being generated from the shader graph. Open up some kind of text editor thing. I'm just going to open up a C# script and then, yeah. You had to think about that for a second. Oh, come on. And then what you can then do is then post that shader graph code that's generated from it. And then if for performance, you can then sort of move things out, take things. Yes, I do want, this is a new laptop, okay? Like, yeah. Okay, and then. So this shader has a lot of stuff in it, but like, yeah, you can then go in and then trim stuff out and have a look at it and decipher it and stuff. Performance really depends what you're trying to do and for what platform. I'd generally say that a lot of the, okay, whatever. You saw that it's possible. So what I generally say is to the noise node tends to be quite expensive, partly because it has to do a lot of noise calculation. Of course, you can open up each node and then have a look at it and see what code is actually going into it. But yeah, performance is generally case-by-case specific. Shader graph will generate shaders for you. In terms of performance, it really depends what you're putting in. Obviously, more nodes and more calculations, the more interesting it gets. That's probably the best way that I can sort of put it. Yeah. Oh, shall I show you one or two more things, and then do loads of questions and stuff? So we have this shader graph example library, which you can download and play around with, and lots of people are piecing together cool stuff from it. We have a guy who works at Unity called Kejiro, and he does more kind of exotic repositories, exotic examples and things, and some cool stuff. So he's got like this flickering TV type thing, and he's done a dissolve thing. See, everyone does a dissolve thing, but his has got like some emission sort of outline and stuff like this. So Kejiro is an awesome dude. Highly recommended. You not only download his examples, because they're like a lot more complex than the example library, because the example library is supposed to be sort of the entry point type thing. But he is a really cool guy, and he's constantly putting out stuff all the time. One recommended thing is actually to go to his repositories, because it's like Aladdin's cave. He has 444 repositories of just stuff. Not like he's got this voxel man thing he made yesterday, and he just puts it all up there for free. Crazy dude. I think he actually worked on our post-processing system. He's a developer in our Tokyo office, which is super cool. Awesome. So yeah, if you Google Kejiro, you've probably seen all of his stuff before, I'll be honest. The other really cool thing is shader graph is actually on GitHub. So you can actually go to the Unity Technologies GitHub, download shader graph, and actually look at the development that's going on in the backend. You can actually open up the scripts that are used for the nodes. So if you're writing your own custom nodes, you can actually look at the source code that's being used for noise, being used for color, being used for all this stuff, and then sort of start merging things together and understanding how it all works, which is super cool. Another element that's really, really interesting is custom nodes. So we have an article on how to actually write your own custom nodes using the code function node. It's a really cool tutorial. I read it for the first time and then made a basic ping pong node, super basic, but yeah. So we have an API to create your own custom nodes. And I think when people start to build their own custom stuff and put it on the asset store and put it online, that's when really interesting things come to be. We often find that when people start customizing stuff, we ourselves are like, how did they do that? That's awesome. The Unity community is very wild. I like to describe it as kind of the Wild West of people just doing lots of really wild and amazing things. I'm logged out, but I don't really have anything other elements to say. I'll leave up this example, and all the other things are cross-posted from here. If anyone has any questions, other questions, I will take them. Or oh yeah, go for it, dude. Well, you don't have to do that with the custom node. So I only said the noise node is expensive in comparison to, multiply two values together because it's generating all that stuff. You could just have a noise texture already made beforehand because, I'll be honest, a lot of people aren't going to really notice the difference. Have a normal noise texture, sample it like I did with the spider robot texture, and then because you get the RGBA channels, you can then get those channels. And then I don't know, maybe tile it and play around with it. So that would be one way. But then what you're sacrificing that you're gaining in you have another texture in your project, and it's another thing to use. So yeah, so there's always sort of different workarounds and different things you can do. I actually found that a lot of the terminology in our shader graph system, in terms of the nodes, is tried to be as close to kind of the current API of writing shaders in Unity, and also just general terms like step, noise, and things like that. Partly so that people can read, say, a graphics paper released by, I don't know, Valve for Team Fortress 2, because they've written a really cool graphics paper on doing toon shading for TF2, and then sort of apply sort of theories and apply sort of values into the shader graph. We try to make it sort of as close as possible to that. Yeah. And I think on the forums, there's like a graphics beta section where we have like a shader graph thread and script render pipeline threads and things like that. If you do have feedback, our developers are in there, and I'm in there somewhere, trying to help people. Go there and write down feedback, because they're gathering feedback for the first release, which is very soon, and then subsequent releases after that. Yeah. Magenta guy.
Could you repeat the question for the camera?
Oh, of course, yeah.
Any particular reason for the shader graph being only in the lightweight pipeline?
So we're doing, so the built-in render pipeline is kind of everything in one shoved in. And it's kind of grown over that over the course of Unity's life. And one thing we're trying to do now is integrate the scripted render pipelines so that people, like in the keynote, like people can target HD or lightweight or custom or tune and things like this. And part of ShaderGraph's intention of exporting for that is to kind of future-proof for the future, because eventually people will be using scripted render pipelines in their project. We're still going to keep the built-in one whilst we shift over to these new systems. But also partly to help people in actually kind of understand the new shader architecture that we're releasing for these render pipelines. We've kind of gone in and kind of, a lot of people say, oh, we want you to update these systems, but don't change anything at all. And we're like, oh, well, OK. So what we're trying to do is slowly, gently show how you would write shaders for the render pipelines with the new libraries that we're putting in. And you can actually have a look in. They're in here somewhere. I'm not going to go through and click through.
I mean, like, will it work with HD?
Yes. So currently, it only works with lightweight, but HD is in one of these branches very, very, very soon. So the render pipelines that we distribute, it will support those. And then you'll be able to see the code and output from there. So yeah, what we're trying to do is upgrade Unity's graphics, which allows you to have decals, allows you to have all this stuff, but then kind of help people wean into the new render pipelines, because they get all this extra cool stuff. And tomorrow I'm giving an SRP intro, lightweight. I'll be sort of doing another tip of the spear type. Hey, here's how you set it up. Hey, you now have decal system, super cool. And hey, you now can do this with lights and stuff. So I'll be doing that tomorrow and sort of showing a bit more of that. So yeah.
So I don't know if it's working. Is it all right? So with what you were doing with the sprite sheets, with the materials, being all noisy and doing all the normal map and stuff like that, is that possible for UI as well? And would it be slowing down the performance based on like the interactions with the UI? Like, can you do that for like a UI element for some sorts, like he did with the screen, like on the TV?
Yeah, so you could use it for basically anything that can take a material in Unity. You can create a graph for. Our workflow is for UI, because UI requires specific stuff in terms of the per renderer data and various UI clipping, masking stuff. It needs to be better. Same with sprites. You can do it with sprites, but the workflow isn't as nice as it could be. So currently, it supports mesh renderers and stuff. That's what it's made for. And then we're working on other nodes and other master setups to output for 2D and output for UI and things like this. So you can do it. I've put a full screen gradient on a UI element, and it works. So that's super cool. But in terms of performance, we need to create those master nodes, and that's what we're going to be doing. So that's more performances in the pipeline. We want to get the tool out and then sort of make more performant systems that make sense. UI being one, sprites being another, possibly particles and things like that. Cool. Oh, image effects and various things like that.
Do custom nodes get previews, visual previews?
Yes.
Or, okay.
Yep.
And are they configurable, or is it just kind of decide based on what you're outputting and inputting into that node?
Interesting. I know that custom nodes do have previews. They have the little preview window at the bottom, depending what you're inputting and depending what you're outputting as well. Whether they're configurable or not, I don't actually know. If you hang on, I'll put up my email somewhere. If you send me an email, I'll then try and get the developers to like write into the docs something. Yeah. There we go. Good old Notepad saving the day. You can tell I'm not a Windows person, right? Anyway, it's just andyt@unity3d.com. Go for it.
Would it be possible to convert existing graphs built in other tools to this system?
No.
OK.
However, so no, partly because this tool's, the API and everything, completely different to how Shader Graph, completely different to Amplify, completely different to other engine systems and stuff. However, I found so part of my job is playing with stuff early. When you have no documentation, no tutorials, no one's using it, some people don't know about it, all this stuff. So it's like, oh, great, like where do I actually learn this stuff? I actually found going through ShaderForge tutorials actually helped a lot because a lot of the nodes are the same terminology and the same system. Like the other day I had to do inward faces being colored something different from outward faces. And I was like, oh, how would you do it in Shader Graph? But the trouble is it's still a new thing. So I found a ShaderForge tutorial on it and just like duplicated the same node structure and it worked. So I'm like, oh, cool. So because of the terminology is a lot the same and the structure's a lot the same, although I think ShaderForge is right to left, whereas this is left to right. Or I think ShaderForge you can flip it now. I can't remember. Yeah, so you can't, there's no import button or something like that, but a lot of the same systems, they do work like together in terms of node structure and things like that. Cool, sorry. Cool, magenta guy.
Where can we add suggestions? Where can we send the suggestions?
So there is on the Unity forums, you can either email them to me or you can go to the Unity forums. Unity beta. It's currently in beta, but when it gets released, I assume there'll be a dedicated forum thread somewhere. Well, there has to be now. It's on camera. Underneath betas and experimental features, there's one for graphics. There's one, oh, you see, people are actually responding to me as well. There's one feedback wanted shader graph. And inside there, you have Matt, he's one of our developers, going in, posting about, this is like early tutorial on how you actually set it up. Matt and a bunch of other people posting suggestions and feedback, and then a developer saying, hey, that's planned for soon, or hey, we didn't think about that. A lot of it's stuff that is on their plate to release, but they're sort of releasing the first version and then adding the other things. And the beauty of the package manager is that they can update the system independently from Unity releases. So rather than, oh, we have to wait till 2018.2 comes out for, various cool stuff, I'm not going to promise anything, they can actually update the package and package manager and push out things quite quickly, which is super exciting and super cool. So actually some features I've asked them about, they're like, oh, it's coming in between 2018.1 and 2. And I joined Unity when we just shipped 4.0. So that's a weird concept for me, because usually I'm like, oh, I'll just wait until the next big release, 3 or 4, whatever months later. Now it's like, oh, could be next week. And I'm like, that's pretty nice. Cool. Oh, sorry. 2018.1. So if you download the 2018. The timeline, so repeat for the camera. If you download 2018.1 beta now, it's available. Like everything I showed you is doable now. 2018.1 is aimed for next month. Yep.
Is there any nodes to work with subsurface scattering?
So the question was, is there any nodes to work with subsurface scattering? I think so. I haven't attempted it. I think the HD one should. Let's just try. I don't know off the top of my head. There should be, I think the HD render loop will have some, but if you actually send me an email, I can then ask the developers and say which node. I've tried to keep on top of all the nodes that are in there, but it's almost impossible because they keep adding more and changing all the existing ones every now and then.
I was going to ask you about the VFX pipeline for this kind of stuff. You said that it was coming soon for the particles and such, because I saw the cube man thing that guy did. What's his name again?
Kajiro.
Kajiro, yeah, he did like that VFX work. Was that all in like Unity, like in real time? Or like?
Yes, so that cube man is all real time in Unity using the new ECS entity component system that was talked about in the keynote and various other things in the past. That's all stuff he's doing now for current beta build and things like this. In terms of integration particles, because in Shader Graph there's a vertex color node, you can actually already set things up with particles. So I've already got these are super basic examples. But like, okay, here are like 12s, and then, yeah, so there is support for doing, generating material, generating a graph, applying it to a material, and applying it to particles. There is support for doing that now. But there are more things we can do in terms of when you talk about GPU instancing and stuff like this. So there's more we can do specifically for particle workflow, but for the first release, it's just for any meshes. And then I assume we'll make more master nodes for different things. Like, yeah, I know that they're talking about like master nodes for like post-processing and stuff like that. So that's super cool. Yeah, cool. Everyone's now hypnotized by spirals. Yeah, so I will be hanging around. If you want to chat about different things, I'll be around. I'm giving 2 talks tomorrow. I think they're full, or maybe people are here already coming to it on the SRP system. So I'm going to be another tip of the spear type, how to set it up in the editor, type spiel. And I hope you have a fantastic GDC. And let's hope the weather remains sunny. You know, I fly from England where it rains. I'm like, I'm going to California. It'll be really hot. And then it's not. So yeah, thank you. Cheers.